All right, we're going to take a look at graphing a parent function and then the transformed function, and I'm going to include at least 5 points. Let's start by taking a look at the parent function. The parent function's vertex is at 0, 0, and it goes 1, 1, because 1 squared is 1, 2 squared is 4, 3 squared is 9, however that will not fit on this graph. I'm going to reflect them over the axis of symmetry or the line of symmetry. So here is my parent function. The parent function name of this we can see by that square and the fact that it's a parabola. This is a quadratic function. The transformations, there's only one transformation that happens according to this equation, and that would be right 2. Remember, it's opposite world inside of the grouping symbols. So the fact that it's a minus, that really means it's right. So I graphed the parent already. Done. Now I'm going to use the transformation rules. I'm not going to use a calculator. Since it says right 2, what this really means is every one of these points that I just plotted, I'm just simply going to move to the right 2. So the first one, I'll move the vertex over 2 places. And then I have this one, 1, 2. Now I can also just say, hey, there's no vertical stretch or shrink. I can just recopy the parent function, but I will keep moving each of these in 2 places to the right. And now as you can see, here is my new function, g. Here is my second example. This one I can tell by the straight lines that this is an absolute value function. The transformations, I see 2 transformations. Inside the grouping symbol, I see a -2, which would be right 2. And then outside the grouping symbol, we have -3, which is down 3. So graph the parent function. The parent function starts at the origin, and then it's a 1-to-1 relationship because the absolute value of 1 is 1. The absolute value of -1 is 1. Absolute value of -2 is 2, and so forth. There's my parent function. Now I'm going to use the transformation rules to graph the transformed graph. So what I'm going to do is I'm going to take each point, I'll move it right 2, and then I'll move it down 3. I'll start with the vertex. So the vertex would be right 2, down 3. 1, 2, 3. The next point, right 2, 1, 2, 3, down 3. And now we have again a 1-to-1 relationship. I can just continue. Right 2, 1, 2, 3, down 3. And there is the transformed function.